Hello, everyone, and welcome back to another episode of Cloud with Chris. You are with me, Chris Reddington, and here we talk all things cloud. Now, thank you for joining, and thank you for the help with the recent milestone as well. We've reached 1,000 subscribers on YouTube, which is really awesome. So thank you for all of the support, the love, and thank you also for just tuning in and watching these episodes. I'm glad that they're proving valuable, and as I've said all the time, please let me know what is valuable, what isn't so valuable in the comments, and I'll make sure to bring on some additional guests with some great insights for us to learn from and to get some more brilliant information. Now, for today's topic, we have got something again, going back, I guess, a little bit into some of the heritage that we've had on the show. We've talked a lot about cloud architectures and different patterns, design patterns that we see come up. We've got a really interesting talk here and conversation to have about microservices. Microservices have communication issues, especially when they fail. So I guess we probably don't want them to fail, do we? Which is where I bring in Francesco at this point to tell us all about it. Hey, Francesco.
Hey, Chris. Yeah, especially when they fail. That's right. Yeah, that's the most frustrating part of handling with microservices.
That's it. And the thing with microservices as well, it's not like we're talking about one or two. We've probably got tens, hundreds, or some cases thousands, depending on the platform that we're building, right? So the challenge grows and grows as we continue down that path. But before we go down that path, we should start with some introductions, of course. So over to you, sir.
Hi. Hello, everyone, I guess. I'm Francesco, as Chris said. I'm an Italian software engineer with a keen attention to cloud architectures and cloud solutions. I'm currently based in Dublin, and I work for a therapy clinic there, if you might know. And I'm currently enrolled for taking care of the call center architecture and multiple different kind of cloud solutions.
Super. And so I guess the things we're going to be talking about aren't just theory. They're actually things that you've lived, you've breathed, and you've had to come out the other side with the battle scars. And, we're going to be learning from those. So thank you for sharing, because I know being in tech, sometimes we don't like sharing those times where things maybe have gone wrong. And, we've got to learn from those things. So looking forward to the discussion.
Yeah, indeed. I totally agree with you, Chris. In fact, failures, as the title of the presentation says, is basically 75% of the time what a software does.
Right.
And we should, act somewhere. Or even by only presenting the errors to the user is one thing, but we should do something after something goes wrong.
Yes.
We should, because it's not important if you can catch all the errors, but actually how you react to them. If you can, get back up.
Yes. Yeah, exactly. It's all about having those good kind of cloud principles, I guess, not designing for failure. I think that's the way we call it, isn't it? Not thinking that it won't happen to me, but when will it happen to me? It's going to happen at some point, so I need to be prepared for that. Exactly.
Yeah,
good. So then, where do we start? I guess microservices we're probably familiar with as a concept, but do we want to maybe? I suppose that could be the whole session on its own, defining what a microservice is, right?
Yeah.
So maybe we'll skip past that one. But where should we start, do you think?
Okay, so let's say that, well, you got a good suggestion there. Let's say we have software in general. Okay, then we have different kind of architectures. We have the old and gold monolithic kind of architectures. Then we have the serverless at the other hand of the spectrum. And then right somewhere in the middle, we might have the microservices. Microservices are just basically monoliths, okay, but they are divided into domains, as we like to call them. We can have different piece of software that handles orders from our e-commerce. On the same e-commerce, we can have other services that actually handles communication with the users, such as emails, WhatsApp, etc. And or we can have stuff for the cart of the so e-commerce. So yeah, basically those are really vertical and specific piece of software, microservices. That's how I like to define them, basically. And
Just to jump in on something you said actually as well, which does amuse me. I see come up a few times. You mentioned about like that monolith and then kind of breaking down by domains. And I guess the whole fundamental of this discussion we're going to have here is the delicacy and the difference between having a distributed monolith
Mhm.
and a set of microservices,
Yeah,
I suppose.
yeah, because you might have noticed that when new concepts and new things basically comes into the public,
Mm.
there are lots of examples of not so well applied,
Yep.
say, practice.
Yes.
You can find out, as you said, standalone monolithics. So
Mhm.
basically, those are monolithics, but they are not quite actually treated as microservices, because uh, microservices have other stuff that actually are around the the piece of software, the business logic. We have stuff such as the communication between all of them, or
Mhm.
in other cases are the orchestration, and other different kind of stuff such as the failure handling. So not all the let's say, as you said, standalone monolithics are actually microservices, as you said.
Yeah, yeah, indeed. And that starts introducing these challenges because no longer are we doing these calls within an application where we can be pretty guaranteed that it's going to happen. Obviously not always going to say that because services can crash and processes can crash, of course. So not always, but less likely than, let's say, over the public internet. Is that message going to get delivered? Is it even going to reach the other service? So that's maybe our starting point, I suppose.
Oh yeah, totally. Well, I'm gonna bring up my personal case,
Mm,
so that actually it's clearer actually
sure.
how we wanted and why we needed to actually uh, manage consistently failures in our microservices architecture.
Mhm, mhm.
So at the beginning, I actually was appointed into the team for building the payment gateway for our newcomers. So you can
Nice,
actually,
easy service,
yeah, of course,
no
yeah,
no
no
criticality to
sweat.
it. Yep,
Mm,
yep,
lovely.
great.
And you can actually imagine, the kind of importance and the
Mhm.
level of attention needed
Yes,
for
yes,
a while,
yes.
while before designing and then developing the solution.
Mhm,
So the second thing that I wanted to bring up in this story is that our current solution needs w- our current solution needs to blend into our company current workflows,
yes.
which of course is old and uses different kinds of third-party softwares. Some of them are still on a SOAP, kind of uh, say service APIs,
Yep.
and others are REST APIs, but only with partial XMLs or JSON files, and
Mhm,
documentation, of course, it's always against you.
mhm.
So we needed to process payments and the different parts of the payments, such as orders making, shipments, and etc., which were handled by different parties, to be orchestrated, synchronized. And
Yes,
of course, you have multiple steps, and
yes.
multiple steps can fail. That's the key.
Mm. And it gets challenging, doesn't it? Because I guess at this point, as you've mentioned, you've got these different, I'm going to try and not use the term services, but different functions, if you like, of an application, which are presumably owned by different teams as well. So they each have their own kind of, not agenda, but backlog and priorities that they work on. Just because it's important to me doesn't mean it's important to the other pizza team, to the other pizza team over there. So there's that kind of wrangling of influence as well. And what happens if I make that change to what I'm expecting to see or what I'm expecting to send that
Yeah.
actually the other teams aren't prepared for as well.
Yeah, and on top of microservice communication, also team communication comes into play in this kind.
And politics as well. Yep.
Yeah, of
Yep.
course. Yeah, bear in mind that gets 10 times more complicated when we are talking about different teams in different companies.
Sure.
So yeah, so that's actually our case. We
Yeah.
were
I
so
suppose
we
payment gateway. Yeah. Yeah. Yeah.
yeah we were basically and we decided to go to the to first of all replace our payment providers. So
Sure.
we went from a really old actually company to Stripe. Okay, really well
Yep.
known, well used,
Sure.
because we needed to have both of the experiences, both on um, online, so with checkouts, etc., and on site, so terminals. So we have both of the ways of communications, and we still needed we wanted one gateway to handle basically all the common transactions and patterns. So we went on and we started to design a first version of this payment gateway, which needed was actually only a set of APIs, basically a proxy to Stripe, that were simply registering the payments, confirming that, and all the needed stuff. Then here comes the complexity. The second step, we wanted to introduce our third-party software for orders, and for registering actually our payments for finance people. And that happened. We then introduced different APIs, different steps, and of course, we hit our first limitations. First of all, an HTTP call have a 30 seconds, let's say, hard limit, and well, you don't know how much a third-party software is gonna take. First
Nope.
of all,
Yep.
not at all. Second, we needed a way to encapsulate and control those steps. So that's how we went. Okay, we need to investigate and see if there is, of course, in case of failures, because also we needed to react when
Yeah.
one of those third-party actors were failing. And so we went on investigating. They released the hunts, let's say, to scrape information and data patterns that we wanted to use, and we found out that a good solution for our problem was the so famous Saga pattern.
Yes.
Uh, that actually, Microsoft pushed a lot into their documentations.
Yes. Yeah. Yeah. And it's interesting, actually. I think as you were explaining earlier as well, I picked up on maybe a couple of additional patterns as well when you were talking with the APIs. Like you had that kind of facade by the sounds of it, where you're kind of stripping out some of those other APIs and then doing the strangler pattern, moving away from the kind of one older scenario, I suppose, into the kind of newer APIs that you're using as well. But yes, as you say, then you adopt this microservices model, you don't know how long this third party is going to take, and you've got to have some way of being able to not just send those requests, those
But
messages.
control.
Exactly. And what happens if something goes wrong? How do you roll back if there's a series of steps and a series of microservices that you've had to call? How do you orchestrate all of that?
Totally, and it was basically a first of all nightmare because we were so damn scared of that, because
It's not easy.
you'll never know. Yeah, it's not easy, and you'll never know actually, because it's not your work. It's not something that you say, okay, I'm actually confident about it.
Yep. And this
So-
is why I always say you're only as strong as the weakest link in the chain. And if you, the amount of times I've had conversations with customers, with developers, whatever, and we're kind of looking at the architecture and like, yeah, we designed this, it's super solid, it's like 99.999% available because of this. And it's like, okay. And like you say, so where does that payment go? Oh, this goes to this thing. Okay, and what happens if they go down? Oh, so many times, because you just think, oh, someone else is dealing with that, not my problem.
Yeah, that's I should say that's a double-edged sword, because it lets you, people that are doing this kind of black boxes, okay, it lets you have a peace of mind on developing stuff, but at the end it's something really not so good for other people who are actually using
Yep. Yep.
your solution.
Yes.
So yeah, as I said, we went on with this Saga pattern. We felt actually really confident about it, and of course, there were hiccups during the way. We decided to, let's say, go on a hybrid way between microservices and serverless.
Right.
First of all, because we had the majority of our code base deployed on a serverless architecture,
Mhm.
and so we wanted to stick to this pattern. And second of all, because since we wanted this to be fastly deployed and usable, we didn't want much of the hassle of managing instances and etc. Even though we had the expertise, but we wanted to have small, fast speed,
Yep.
faster deployment cycles. Anyway, we went on. We designed for failure, let's say, this gigantic multi-step transactions. That's how we call them. So we went on. We laid out the basic design of the, in business logic terms, I mean, of the process. So the transaction starts. We have all the information related sent from the client, and then we basically start this fire and forget transaction. Underneath, under the hood, is basically AWS Step Functions,
Mhm.
as you may know, which basically handles the different routes and fallbacks. And on that, we were planning different kind of scenarios because, of course, it's really difficult, if not impossible, to design a flow that rules them all. So we went on for the first easily, low-hanging fruit that we could. So 2 single steps, perfect as it is, with rollbacks. We tried the first time, and of course, it blew on our faces totally. Because the first, let's say, hardship of implementing this kind of patterns, because we have to always remember that, yeah, they're really handy, they're really powerful indeed, but you need to do it the right way, because
There's no
otherwise,
shortcuts. Yep.
yeah, exactly, because one time or the other they're gonna basically blow up.
Yeah.
So the issue that we're currently facing in the first steps was uh, the issues about rollbacks and actually deciding what kind and uh, where to do those kind of rollbacks. Luckily for us, this was just more of business related issues. So we just went back a step in the development cycles and went back to product people to decide about this. Then, after that was basically sorted out, we went on trying out adding more steps. And the second hardship that comes to this is, of course, communication. And that's where, we say that microservices have communication issues. We needed a way, of course, of communicating both to us, because we needed some sort of observability over the different steps, what's happening, etc., and to the clients. If we wanted, for example, to real-time update the clients, because okay, we are doing this step, this thing, and we are actually finishing the process. So we needed a way of communication. And of course, on top of adding the way of communication, we needed to decide which is the component responsible for this. And we actually went on again, designed a new solution for this, and basically tried to implement a middle way between having a separate, complete, dedicated, let's say, event bus or structure, something that we're handling, communication with the internal parts, or actually leaving everything to the different pieces. In our case, all the different pieces were handled by lambdas, okay, AWS lambdas.
Yep.
So each piece of code was loaded and executed by each one of the lambdas, and all the steps were or business logic steps or rollbacks for those
Yep.
steps.
Gotcha.
So in order that we have this pair of steps, that we could just like Lego building in the flow that we wanted. So we decided, as I said, in a middle way of these two extremes. For example, the final solution came up to be for as a, let's say, communication between the lambdas handled by the step functions itself, so passing parameters, etc., and the communication to the clients or to external parties, okay, was handled by an event bus in this case, to which each different kind of subscriber were on, such as webhook subscribers, AppSync, or in this case, WebSockets subscribers. And that actually was, I have to say, I have to say that it was like a really lot of work, because it was on top of that, it was really a matter of synchronizing the different things. We were also relying on some some managed services, AWS services, for this kind of stuff. I'm going to tell you, we were basically receiving the updates to these transactions via the DynamoDB triggers, okay, to which we were also needed to synchronize them, like, put them in a proper order of happening, because we needed to propagate those to different clients. And yeah, that's basically how at the end ended up. And I have to say that it's currently on production, everything. And it has been working for weeks, basically. And just not to brag about it, like generating, like, I'm talking about thousands of euros and pounds of revenue, basically, through this payment gateway. And it's scary. I mean, it's always scary. You can be as confident as you can, but seeing all those numbers and the number of executions and transactions being executed, it's simply scary. Way.
And just for anyone who's kind of listening in and thinking, I've got similar challenges, or I've got similar issues, or I've kind of been on this path, how long did it kind of take you from that, let's say, starting the project at the beginning, getting to that one stage of that initial version where you realized it wouldn't quite work as you'd needed to, then having to do that refactoring and getting to now?
So let's say first iteration, roughly 2 weeks, okay, to be, let's say, production-ish ready. Okay, because we never actually deployed to production the first version, because we went to, since it was related to payment, we went to extensive testing for that. But yeah, let's say roughly 2 weeks. Talking about only backend side, of course, roughly 2 weeks, and then the other, from, let's say, working to resilient and robust, let's say, solution, was roughly 1-2 months, something like that. Especially because, as I said, I'm going to reiterate, it was related to payments, so money, really, we needed to be really careful about that. Plus, it was multiple team effort.
Exactly, and it wasn't like a trick question just to kind of see, how long did it take? It's interesting seeing the time it took for the POC and that kind of simpler assumption-based approach versus the, right, let's actually use some of these patterns, adopt it, solve the hard challenges, because actually what we're doing here is business critical, and we need to think about this the right way and test this the right way and work with the right teams to make sure we're getting the right inputs as well. And these things take time. And I can imagine those 2 months weren't just development effort. It was all the stakeholder management, all of the probably the testing, and looking through probably things like compliance and other things as well to check,
Yeah.
and
Yeah,
lots more than the
yeah,
engineering.
totally. Not only, yeah, as you said, not only like development time involved, because a lots and lots of time was also involved into talking and meeting with relevant stakeholders, such as the finance people, etc., which has their own schedule, their own
Yep,
time,
yep.
etc., which is another piece on its own.
Hmm.
So yeah, we needed to find the sweet spot between being fast developing,
Yes,
but still being confident about what we develop.
gotcha.
So
So I
yeah.
guess then, starting again, you'd go for the Saga pattern, make sure you've got that in place so that you can, be able to play those back and generate as you need to and orchestrate. If you were either going through this again or maybe kind of coaching or mentoring someone who was going to go through something similar, what else would you maybe get them to think about, like broader than just the immediate problem? And there may be like ways of approaching things that you would do differently,
Mm.
asking the
Well,
hard questions.
yeah, yeah. Like, because when you do something, it works for
Yeah,
once, you
yeah,
think,
yeah,
okay, I'm perfect like this.
yeah, yeah, yeah,
Yeah, but yeah, it's just if let's put myself on this situation that you picture.
yeah,
Like,
yeah,
okay,
yeah,
I have to mentor, like, say, tell someone how to do
yeah.
this, or like follow this person. Well, the first thing is, I'd say to this person to focus on the big picture. So, like, approaching the problem to top-down procedures,
Sure,
because
sure.
all because all the moving parts are important to this piece. And since it is a problem about synchronization and or orchestration between
Mhm,
pieces, it's always good to have a clear big picture.
mhm,
You won't know how many times me and my team went back to our boards and just redesigned or rechanged
mhm,
the big level design.
mhm,
And of course, first thing. Second, advice that I could give is uh, have always an eye for testing, first
mhm,
of all, in the first place, and where actually the communication happens. So uh, don't build services, or actually functions in this case, to be executed for their own self, so for
mhm,
their own sake.
mhm,
Keep in mind that they are actually part of a bigger structure.
mhm,
So, and also how these should actually communicate,
mhm,
how the whole system should communicate to the outer world, let's say.
mhm. Yeah, gotcha, gotcha. So keeping that overall view in mind, not getting siloed on one piece of functionality and then maybe forgetting almost some of those broader requirements that maybe they're implied, that maybe you didn't pick up on or wouldn't have thought about because you've kind of gone that bottom up approach, I guess. Got it. Got it. And apologies, by the way, for my video disappearing for
Oh,
anyone
no worries.
watching. It's very hot here in the UK right now, and my camera doesn't like it. So there we go. But you still got my
Oh.
voice. Um, gotcha. Okay, that makes sense. I guess then, would there be anything else maybe before we could start wrapping ourselves up here that maybe you'd want to cover, Francesco, or would that be maybe a good point, do you think?
Well, uh, well, I'm thinking about maybe something related to uh, observability about this point, because
Mm,
yeah, we always have to bear in mind that since those system gets so complicated, we need one point should be set to, let's say,
yes.
attention, to observe those systems, because
Yeah.
one thing is actually uh, okay, receiving an error and reacting to that, but
Mm.
you see, you can't react to an error if you don't actually receive it.
Yeah, and it's even harder than that, isn't it? Because we're in a world where we're now running a distributed system, distributed services, and Yeah, sure. We could understand, hey, is this processor working? Is this receiver working? Yes, no, fine, fair enough. But you mentioned something earlier really important about these kind of business processes. And something I meant to come back and say, by the way, was that when we think of rollback, we don't even necessarily mean like database rollbacks. It's like state changes and things like that that might be different as well. There's lots of different areas that could go in from that perspective. So even having the observability into that business layer as well, and what that business kind of level insight is happening as well is really important, not just the kind of core technical running, I suppose.
Oh yeah, exactly. In fact, multiple payments, okay, transactions. So not only you have a multi-steps between different kind of parties, but you also have multiple payments, okay, for one single transaction. For example, if you pay with two different cards, okay, you have to process actually two different payments, but
Right.
it needs to appear as one big transaction. So the first question that comes into my mind is, what happens when half of them goes through, or only one of them? What do we do with the rest? what's what's our course of action? And that's actually was the latest stream of work that got us busy into my company. We went on and decided on how to handle them. In fact, we actually didn't put any rollback in that case, because we
Right.
needed a human
Right.
to act on
Yes.
refunds,
Yep.
on
Yep.
what should be happening. And that was actually the case of simply mm, notifying us technically on our Teams channel in this case, and
Yeah.
actually posing these message to the user to say, okay,
Yeah. Yeah.
these transaction failed, these payments failed. What do you need to do?
And do you know what? I'd really want to just jump in on that one a minute because that is a really great example of where someone might be very tempted to over architect and go, oh, we need to reverse this out, get the user to go and do this again, and then go and, but actually, you know what is for the amount of times that's probably going to happen, which is arguably probably low. I'm making assumptions here, but say it's a certain percentage. You got so many transactions going through the system at any given point. Is that engineering effort worth that particular edge case? Is then the scenario you got to weigh up and the complexity that it then brings. Because when you start bringing really complex edge cases like that, what does it actually impact that maybe you haven't considered other kind of edge case scenarios? And, you know,
Yeah,
simple is often the best way, right?
yeah, it's always the what's called the Occam razor. Try
Yes, yes,
to
yes.
stick to the simplest process first, and
Hmm.
you might find also that it's actually the right one, the most profitable one, because
Yep,
we as an engineers, we need to first of all think about how profitable is our time
yep.
and where to allocate our time. As you said, we
Hmm.
need to say, okay, is this an effort that we want to take on?
Mm.
Yes or no? And
Yeah.
that's basically decision on our shoulders.
And it
But
comes
yeah,
back
that
to
time
DevOps.
this time we decided,
Yeah. So
yeah,
sorry, I
a
think we
lot,
have a bit
lots
of
of.
a lag between us, but
Oh yeah,
it
no problem.
comes exactly back to DevOps that it's all about that value to the end users, and what we focus on really needs to be driven by what is going to be valuable to our end users, and as you say,
Yeah,
profitable, and that is key.
yeah, that's why on top of that we went at the start for a more, not a fully microservices, let's say, way, but more of a hybrid serverless
Yep.
managed way.
Yeah.
Wanted
Gotcha.
to focus
Gotcha.
on the right side.
Awesome. Evolution, not revolution.
Yeah.
That's the way. That's the way. Awesome. No, Francesco, awesome. Thank you so much. I think there's so many
Thank
great
you.
insights. I think we veered away as well from the Saga pattern a little bit and picked up on some other really interesting things along the way as well. But really, really great session. And thank you for joining. I guess any closing words or thoughts before we wrap up here?
Oh well, we should have probably more counselor for microservices, as their communication issues problem. Yes.
I love that thought to end on. Francesco, thank you so much. Really great
Thank you,
session. A
Chris.
pleasure to have you on. There we go, folks. So we have been learning here all about microservices, that they have communication issues, and we heard it there. Many challenges along the way that can crop up when we start building these hundreds, if not thousands, of services, and how they choreograph that communication, I suppose, across all of those. What happens if we need to roll back not just data changes, but thinking of that business process, and simpler is often better. That's something we're always really keen to push and promote here, being pragmatic. So you know what to do here, folks. If you've liked the session, please hit the like button, please hit subscribe, and let us know if you've enjoyed this session, because we can get very similar sessions like Francesco's coming up as well, talking about these more real world kind of implementation scenarios and what we've learned as a result. So with that, thank you for tuning in today, and we will see you very soon. Until then, thanks for watching. Bye for now.